So this is the third video that we're making. Number one, it's another absolute value equation. And on all absolute value equations, you have to first isolate the absolute value, which it's already isolated. And then after that, we need to set up a positive situation and a negative situation. Now, the positive situation is writing it exactly the way it is, except you don't put the absolute value symbols. It's just without it, exactly the way it is without it. The negative situation is going to be writing it exactly the way it is without the absolute value symbols. And you have to change, if you had an inequality, you have to flip the inequality, but if you flip the equal sign, it's still going to say equal. But you also have to change the sign of the right side. Now what that means, you need to multiply everything by -1. So you're going to have a negative 5w and a negative 28. Let me write that out. You're going to have 4w minus 1 equals negative 5w minus 28. Okay, so let's solve the positive situation by adding 1, canceling, adding 1. We're going to end up with 4w equals 5w plus 29. I probably should have moved the w over first, but it's okay. Cancels, 5w. So you're going to end up with negative 1w equals 29, which means that your answer is w equals negative 29. Agree? Okay. Let's go for the negative situation now. The negative situation, we're going to add 1 to both sides. We're going to end up with 4. Whoa, what is that? That's disgusting. W equals negative 5w minus 27. And then we're going to move the 5w over, plus 5w plus 5w. You're going to end up with 9w equals negative 27. And then we're going to divide by 9 and divide by 9, which means that w equals negative 3, correct? Okay, so on your multiple choice test, if you see both of these answers, like option A is negative 29, negative 3, and you bubble that in, guess what? It's going to be wrong. Because we're forgetting one detail. Since the w is on the outside, since there's a variable on the outside of the absolute value, we have to double check our answers. Because we have to plug them back in. I need to take this negative 29, plug it in here and right there. And then after that, I need to plug in the negative 3 into the w and into the w. Right? If it works for both, well then yeah, both of them are my answers. It might not work for any of them. Then you have no solution. Right? But let's test it out. And we could just walk through it or even think about it very logically. Check this out. Let's say I wanted to think of this negative 29, yeah? If I think negative 29 right here, 5 times negative 29, what kind of number is that going to be? It's going to be huge, but negative, correct? That's going to be like negative 145, right? Plus 28. What's negative 145 plus 28? That's a negative number. That's the bottom line. It's a negative number. And what do we know about absolute values? The answer is always what? Positive. So if I were to plug in the negative 29, and I think about 5 times negative 29 plus 28, it's still going to be a negative number. So we know that negative 29 is an impossibility. I'm not even going to bother plugging it into the w right here, because whatever I get in there, it's going to be a positive number, and a negative 29 on the outside is going to give us a negative number, and we know it's impossible for an absolute value of something to give us a negative number. Does that make sense to you guys? Okay, so let's look at the other one. If I were to plug in this negative 3 right here, all right, that's going to be 4 times negative 3. 4 times negative 3 is negative 12, and then I have this minus 1 right there. So that's going to give us a negative 13 inside the absolute value, right? Which is going to ultimately be positive 13. Now, if we look at the other side and plug in negative 3 over here, 5 times negative 3 is negative 15, and negative 15 plus 28 really is positive 13. So this is 13, this is 13. I probably should be showing my work, but I hope you guys are following me. If I plug in negative 3 right here and I work it out, I get 13. I get positive 13. If I plug in negative 3 right here, I'll get negative 15 here, plus 28. It does give me a positive 13. So it is a true statement because both sides are equal to 13 when I plug in negative 3 right here and here. Does that make sense? So what's your only answer in this case? W equals negative 3. That's your only answer. Now we all are also going to have compound inequalities that we need to solve and graph. Okay, so this one's a compound inequality written together. There's going to be some that are going to be separate with the word or. Those are easy. You just solve the left side, solve the right side. But these are written together. So we need to solve them. And it's kind of like ignoring the negative 11 for a while, ignoring this whole thing and just say, if I had 3y minus 20 is less than 55, what would I do? Oh, well, I would add 20 here to get rid of it, and I add 20 over here. Now, the thing is, that's if I only had two sides. But I have the middle, and I have two outside sides. So whatever I do to the middle, I have to do to both outside sides, if that makes sense. So we have to not only add 20 to the right side, but also add 20 to the outside left part of it. So we end up with 9 is less than or equal to 3y, bringing everything down, is less than 75. Are you with me? And now what's the final step? Divide by 3, divide by 3, divide by 3. We will have y in the middle, bring down the inequalities. Notice I'm not flipping the inequalities because I did not divide by a negative. If this would have been a negative 3, I would have divided by negative 3, divide by negative 3, divide by negative 3, and these guys would flip, but that's not happening in this case. We didn't divide by a negative. 9 divided by 3 is 3, and 75 divided by 3, there's 3 quarters and 75 cents, so that's 25. Now this is a compound inequality, but then it's solved. That's our answer. But on the multiple choice, they're also going to show you different graphs. So we need to be able to know which graph is represented with this answer. So a quick sketch on a number line is to put your smaller number on the left, which it's already there, it's 3. Put your bigger number on the right, 25. Okay? And of course, there's all the numbers in the middle, 3, 4, 5, 6, 7, all the way to 25. I'm not going to do that, but we have the idea here. Now, is this going to be a solid dot or open dot? Solid, because it has a solid line underneath it. At the 3, let's put a solid dot right there. And just by knowing that this is already written together, it's going to be an area that's together. Okay? So this other one's going to be an open dot because it does not have a solid line underneath it. So that one's going to be an open dot at 25. And here's my answer. Okay? That's simple. I mean, if you actually wanted to think about it, okay, let's say y is what compared to 25? Y is what compared to 25? Y is less than 25, so less than's to the left, so you see it going this way. Now let's compare this guy over here. Y is what compared to 3? Greater than. It's opening up to the y, so y is greater than or equal to 3, so greater than's to the right. And that's how the areas are together. So you should be able to identify the graph as together. This one solid because of the solid line, this one open because there's no solid line underneath that one. Moving on. Number 3. Solving graph again. So on this guy, we're going to distribute the minus 5. We'll have minus 5n plus 15. Bring down the 4n right in front. And we could also continue simplifying the left side by combining like terms. The 4n minus 5n, we could do this in our heads. We don't do the opposite or anything like that. You just do it in your head. $4 minus $5, you're going to owe $1, right? So you're going to have negative 1n plus 15, and that's as far as you could go on the left side. Now on the right side, we're going to distribute 3 times n, that's 3n, 3 times 1, that's 3, and we're also going to bring down the minus 8, And once again, we could still simplify the right side by combining the 3 and the minus 8. And we're just going to do this in our head again. We're not going to do the opposite or anything like that. It's just 3 take away 8. That's going to be negative 5. So let me rewrite everything. 3n minus 5, or plus negative 5, whatever you want. Now let's take this inequality symbol and bring it down. So let's bring that right down in between them. There's our new inequality equation. Inequality, I shouldn't say equation. It's not an equal sign. Now let's get n by itself on one side. So it's up to you. You could move the negative 1n over here and have an n on this side and solve for n on the right side. But I prefer to get the n to the left side, because at the end of it all, you want the n on the left side. So we're going to subtract 3n and subtract 3n. We're going to end up with negative 4n plus 15 is less than negative 5. And I'm also going to subtract 15, and we're going to have a new inequality that says negative 4n is less than negative 20. Now for my final step, I'm going to have to divide by negative 4 and divide by negative 4. So what happens to the inequality symbol? It flips. That's right, it flips, because you're dividing by a negative, and your final answer is positive 5. So there's your answer, but it says solve and graph. So to graph this guy, I'm going to go to a quick number line. Now I'm going to put 5. I want to fill in a couple of values. To the right are greater values. To the left are lesser values. Is this going to be an open dot or a solid dot? Open. So that's going to be an open dot at 5. And is it going to the left or to the right? Going to the right. It says n is greater than, so it's going to the right. There we go. Let's move on to the next one. Gonna have to squeeze this in a couple of minutes. Okay, it says write the slope-intercept form equation of a line that has a slope 3 and passes through 5, negative 8. So you need to know what slope-intercept form is. Slope-intercept form is y equals mx plus b. In order for you to write your slope-intercept form equation, you need the m and you need the b. So in this case, they give us the m, all right? Let me underline that right there. They give us the m right there. Slope is negative 3, but they don't give us the b. So we're kind of like out of luck. We can't really do slope-intercept form. What we do have is a point and a slope. So that should ring a bell that we could do it in point-slope form. And what is point-slope form? It's y minus y1 equals m parentheses x minus x1. Now keep in mind that your point-slope form, I put it in blue, that your x1 and your y1 are actually your x and y from your coordinates. So this point is really an x value and a y value, and if you label it 1, 1, you'll know what to plug in where. And we already know that this slope is negative 3. That's the m value. So what I'm going to do, let's make this a little smaller, and I'm going to plug in my values. It's going to say y minus y1, which happens to be negative 8, equals m, which is negative 3, trying to be color coordinated here, parenthesis x minus x1, and x1 happens to be negative 5. So be careful when you have those minus negatives, you have to change them to plus plus. So I'm going to go plus plus here and plus plus here. So we have our equation in point slope form. All we need to do is get rid of the parentheses that you see here, and also move the 8 over to the other side. So let's get rid of the parentheses by, let me first move this out of the way. Let me get rid of these parentheses by distributing. So I'm going to go negative 3 times x, that's negative 3x. Negative 3 times 5, that's negative 15. Over here we have a y plus 8. And final step would be to subtract 8 on both sides. So my final equation will be y equals negative 3x minus 23. Yay? What do you think? And that's it. I'll do another video right now.